You guys familiar with a term called bounce back? There's many definitions for it, but I think a bounce back is when you peg the needle on the end of the scale, it bounces back. BVI got down. Bounce back. Let's get on with the show.
Salvation is reserved for those who pass the test. If you survive, an elevated existence awaits. Initiate phase 1. Power up the brace cannon.
Okay, let's talk about a couple things. Now, there's a gentleman out there that claims he's an amplifier technician. If he is or he isn't up for me to decide. But he clears his throat a lot, and he has a tendency to tap on cabinets. He apparently has no idea what this device is, because he was trying to claim that I passed all the current for this entire box through a little half or quarter amp switch. Now, that's called a 25 amp arcless relay. They're used in commercial applications, and they're designed to turn on huge loads, on and off, on and off, on and off repeatedly. The contacts inside this thing are sealed, hence the term arcless. The only thing that little switch does is runs the motor for the solenoid on the inside, like 1/30th of an amp. That being said, I've been dying to build another one of these. Talk about bridge rectifiers. There's a gentleman out there, likes to clear his throat a lot and tap on things all the time. Apparently doesn't understand that bridge rectifiers work perfect for this particular application. And they're fairly inexpensive. We don't need to use 50 and 100 amp piece stud diodes for what we're doing here. All you have to do is apply the proper amount of cooling. You notice on the inside of X-Forces and Dave Maids and stuff, they just drop the heat sink down in the middle of the cabinet and no airflow can get around the fins. So how's it supposed to pull the heat off the bridge? And the bridge is usually the weakest link in the whole equation, that's true. If I change out that bridge, what else is going to fail? The electrolytics? The transformer? Well, not in this particular device. So they call laminate airflow. And if you look down in here, you can see that the bridges also sit on a piece of copper. So it uniformly wicks the heat back and forth across the heat sink. Now, this is one continuous piece of heat sink that runs the entire length of this cabinet. The airflow is also blocked off over here on this side of the cabinet. So the only way the air that is being pressurized down on this end of the cabinet flows down and through, can exit or exhaust the box, is through the heatsink. Just saying. You can pay a guy to put stud diodes in your box, but it's absolutely not necessary. And it's just adding a wasted expense, a huge wasted expense. We're not talking little 5-watt resistors that I think are cool and actually do work better. We're talking 50, 100, 150, 200 extra dollars to the box that we're wasting for no point. Food for thought. Like I said, I'm not talking smack. Just stating electrical fact. Oh, and the other thing, because I know this gentleman's going to watch that video. Dude, it says right in the first line in the instructions, never ever ever hit your calibrate button or the set button on your peak board with a slug in the hole. And you did it on video 6 times. You need to send your slug off and get it recalibrated because you just burn it up. Same gentleman. Okay, I'm done. This is the BBI 1x4. I'm using a 100 amp, and it's the first time you guys have gotten to see one of these in application. You're going to see a bunch more because I got about 15 more builds that I got to use these on that I've already got sitting here that I have not had a chance to get to. Sorry everybody for the 3 and 4 month delay on new builds. It's just the way it is. I'm busy. I apologize. EPD, 100% made in the United States. I called up Peter and Michelle, and they built these for me. And I said, sell them to anybody. Because I designed them as a direct drop-in, bolt-in replacement for X4s, ICA stuff. And you know, them guys can also call them up and buy these directly from them. Once again, 25 amp arcless relay. Controls 100% of the load of the box. This little switch doesn't do anything. And if you think about it, this is much safer than using a big ass toggle switch that'll get hot and eventually will quit. 1000 watt slug RMS forward, 1000 watt slug PEP forward, 1X position on the PEP RMS. Audio. As always, performs flawlessly. Let's look at the volts. We're idling at 19. My key, it drops to 14.4 volts. Hello, audio. Let me pose you this question. When you hook your volt leads up and you put your transformer underneath the load, does your voltage increase or does it drop? If it's dropping, this is the reason that your bridges keep blowing up. Between that and the lack of ability to dissipate heat. Now let's get set up for another test. I'll be right back. Okay. Let's establish some baselines. Now, a transformer just sitting here idling is at 76 degrees. Our ambient air temperature is 58 to 60 degrees. The inside of the box, it's all about 60, 65. The reason it's slightly elevated is because I was just operating it. Now with those reference numbers, and we're going to look down here at the 66 degrees, 72, 66 degrees. I'm going to key this thing for a few minutes. Hello, audio. Hello, audio. Hello, audio. Hello, audio. Please note the cabinet lid's off. Hence the reason a little bit of harmonics that we're seeing, but nothing major. That's a 5 watt slug in reverse. Going into a 10,000 watt bird dumbing load, and we're throwing a 400 plus watt dead key modulating off the end of the scale. Hello, audio. Hello, audio. Hello, audio. We're actually hitting the stop peg. Hello, audio. On the meter. I don't like doing that too much, but I have to do that to demonstrate linearity. Now we just went to 2x. So now remember, the 50 mark is now 1,000. Hello, audio. Hello, audio. So that's 1,200 peak watts. And we're only on 14 volts. Hello, audio. Now with EPD, Peter and Michelle, I had them add secondary taps. You can change the voltage up and you can make it run underneath the load up to 17 volts. This box does 1480, 1500 watts ish on 16 volts plus. I don't suggest you run it there. I strongly suggest that you don't run it there. Leave it just the way it's set, the way it comes from the factory, me, the builder. Let's look at the input tune here real quick. That's keyed. Nada. 5-watt slug and reverse. Audio. That's 0.2 of 1 watt. Audio. Output tune, input tune, perfectly balanced. Hello BDI. Hello BDI. Hello BDI. Hello BDI. Hello BDI. Hello BDI. Bridges are at 80, 95 degrees. Hell, the pills are hotter than that. 78. Same exact temperature. Same exact temperature. I picked up 4 volts worth of temperature, or 4 degrees worth of temperature. Pills picked up 20 degrees worth of temperature with all that key time. Sure, I'm proud of this. To go from absolutely nothing, an empty case, to completed amplifier and send it out there in the world. And a lot of the products in here I've had a hand in designing. Awfully freaking cool. I am the biggest mud duck in Idaho, and I have just got down. I'm going to button this baby up, take it over to the shipping place tomorrow, and send it away. One more gentleman, 10-8, and I'm 10-7. I'll see you. Bye. Bump, bump.